Hello everyone. Again, this is Tanuki Shirwani with a very good lecture. So, in the previous video, we have talked about the introduction portion of the alkaloids. Today, we are going to discuss about the general structural features of alkaloids. The chemical structure of alkaloids are extremely variable. Why am I saying? Because in the previous video I have already shown you the different kinds of alkaloids with some of the example, like having a very different and variable structure, as caffeine has a very different structure than the morphine. So it has a very extremely variable. Sometimes also students get scared by seeing the structure, so you don't have to be bothered about the that much complexity, okay, and variable nature. Generally, alkaloid contains at least one nitrogen atom in its structure, which is responsible for the basicity of alkaloids. uh, because nitrogen has the lone pair, it can attract the proton, so it shows the basic nature. They are generally tertiary nitrogen compounds and contain one or two nitrogen atoms, usually in the tertiary state in the ring system. So we are talking about the structure. Listen carefully. ये tertiary nitrogen होता है, which is in the inside the uh, you know which is the part of the ring system. Most of the alkaloids contain oxygen. Okay, this is also there. So these are the some of the examples of the alkaloids, and obviously they are found in the plants. So this is a plant, Barbarius vulgaris. This is berberine, structure of berberine, which is alkaloid structure coming from this particular plant. Again, you can see the morphine, which is coming from this flowering plant. This glantamine coming from this particular plant, which is Galanthus nivalis. Salsoline coming from Salsula plant. This is Hippastrum vitatum plant. सब कहीं ना कहीं plant से आ रहे हैं. Different structure. You can see the caffeine here, which is coming from the coffee arabica. Again, you can see the hermine here, which is coming from the Pegnum hermala. You can see the nicotine, which is found in the tobacco and which also work as a insecticide, and this is a very toxic compound when it comes to alkaloid. This is a very toxic. Even 40 milligram of nicotine is being deadly deadly compound for a human being to consume, which comes from the Nicotiana tabacum. General properties of alkaloids. So the alkaloids are usually colorless, crystalline, non-volatile. You know what about the volatile? Volatile compounds are the compounds which has ability to वेपराइज. जो वेपराइज होते हैं वो वोलाटाइल होते हैं. नॉन वोलाटाइल कौन होते हैं? जो वेपराइज नहीं होते हैं. ठीक है. और इनको अगर तुम मतलब फायर देते हो तो फिर वो तरीके से जलते भी नहीं हैं, क्योंकि वो वेपर ही नहीं फॉर्म करते ना. नॉन वोलाटाइल सॉलिड्स विच आर इनसॉल्युबल इन वाटर बट आर सॉल्युबल इन इथेनॉल, ईथर एंड क्लोरोफॉर्म. ऑर्गेनिक सॉल्वेंट में सॉल्युबल होता है और वाटर में इनसॉल्युबल है. सम एल्कलॉइड्स आर लिक्विड विच आर सॉल्युबल इन वाटर, लाइक कोनिन एंड निकोटीन. निकोटीन जो होता है तुम्हारा वो सॉल्युबल होता है वाटर में. ठीक, कोनिन भी. A few are colored. Berberine is yellow. Most alkaloids have a bitter taste and are optically active. These are the optically active compounds. Maybe it has it has no plane of symmetry and center of symmetry, as well as you can also consider it as optically active compound having a lot of, sorry, not a lot of, I chose a wrong word, it has at least one chiral carbon. So the optically active alkaloids are very useful for dissolving racemic acids. Okay, so the racemic mixture is nothing but the so the racemic mixture is basically when the two enantiomers with the different rotation are mixed with the same amount, it gives a optically inactive compound which is known as the racemic mixture. So since it is laboratory, by using it you can dissolve the racemic acids. The alkaloids from insoluble precipitates with solutions of phosphotungstic acid, phosphomolybdic acid, picric acid, etc. Many of these precipitates have definite crystalline shapes and so may be used to help in the identification of an alkaloid. So classification of alkaloid, we will discuss it in the next video.